Welcome to the final track of today's talks. The final speaker today that you chose is Matthias Madsen. Software engineer by training, he developed a strong interest for distributed systems. In 2010, after having finished his degree at Aarhus University, he founded a company together with a colleague, Keat, a file sharing and storing system. Half a year later, they improved it and created Get, ge.tt, which you probably know, which is a widely used real-time file sharing system. He continued his interest into peer-to-peer communication and technologies as a partner at Hyperdivision and CEO at Redporch, right? Redporch, where he's trying to bring peer-to-peer technologies to everyone, including us today. Today he will tell us about his new peer-to-peer app, if I'm right. Yeah. He's also very much into open source and is a large contributor to the Node community, maintainer of, I think, more than 900, according to NPM, even more than 1,000 NPM packages. Yes. And also very large in knowledge sharing, being a frequent speaker at different Node conferences, and also third time here at TNG. By the way, he mentioned the remote conference at TNG was actually the best remote conference he ever had. Nice. So today we're going to learn about the very new, brand new peer-to-peer app.
Oh, I have my own.
Yes, you have your own.
Hey.
Well, warm welcome to Mathias Buus.
Thanks, everybody. So I just had a huge curveball because my computer doesn't work on the screen. So we're just going to test all of it on this new computer. So if nothing works, it's because a new computer. But let's see if we can get it to work. So at least you know it's real. It's not worst case, I'll just hold my computer up and then we can everybody can just huddle around over here. So I'll skip all my German jokes because we lost a lot of time. So they're also not that good. So I'll just get straight into it. But yeah, and thanks so much for this beautiful introduction. It's kind of like when you hear your life being read out. It's unreal. But anyways, so Christoph from TNG texted me like 3 months ago asking if I wanted to speak here, and I've been here a couple of times. I always enjoy coming here because Germany is really nice, and everybody here is always very friendly, and it's super, super nice. And he was like, "You want to come show some peer-to-peer stuff?" And I'm like, "Actually, we've been working on this thing that is super secret for like a year, maybe two. But sure, I'll come talk about that." Just gotta align the dates, and we're actually officially releasing it next week. So I'll give you a preview now. So I have this disclaimer of like, please don't tweet about it. But it's not super secret, but it's just like not public yet. So please respect that. If you accidentally do it, I'm not gonna hunt you down, but I might. Anyways, I'm actually working on a new project that's a continuation of my old company where we only do peer-to-peer technology. It's called Holepunch. For all you non-millennials out there, it's a little transcription. It's a TP2, I can't even say it myself. Peer-to-peer company. So that just means we only work with peer-to-peer technology, primarily in JavaScript and Node.js and a little bit of C. I tried to be funny there and that backfired. So anyways, if you've never seen me before, quick introduction again. I'm Mathias online. I live in Copenhagen, a beautiful city. Come by if you want to. I work at my company, Holepunch. We're around 10 people, all remote. It's very nice. As I was told, I have a lot of stuff online, around 10,000 repos, billions of downloads. I make zero money off it, so that's like awesome. But you're welcome. I enjoy it also. I do make money on my company, so that's nice. So anyways, don't feel too bad. And also, we're hiring peer-to-peer engineers. So if you know anybody, tell your friends. Know anybody who want to work on peer-to-peer Node.js, JavaScript every day, remote. Send them my way if you're not hiring yourself. Everybody probably is. So, anyways, I'm here to talk about peer-to-peer, and I have like a whole app I want to show. It's at the end, but I always want to do this thing where I just want to, people need to learn something every time I talk. So I want to talk a little bit about technology. So basically, I want to talk about why we need to start thinking about the swarm and not about the cloud. So basically, by swarm, I mean tons of computers swarming together. Cloud, boring old cloud, you all know it. So, every day, tons of us use computers. I think in here, everybody probably uses a computer. A lot of those are really powerful. I have 2 up here. I have 1 in my pocket. We also have these very, very fast internet connections, most of us. And even if we don't, we probably have some connection. And I don't know how it is in Germany, but in Denmark, I don't pay per data I use. I just, get extorted for some fee every month. They're like, pay me $50 and you can use all the data you want. I'm sure there's some limit, but they don't say it at least. And like I said, I have tons of computers. When I start counting them, it's like phones, watches now, laptops. I'm probably in the extreme. I have like 10 laptops at home because I work with peer-to-peer, but like still. Most of them I don't use ever. They just lie around. Most of my internet I don't use because I'm doing other stuff. And it's kind of sad. It's just going to waste. So we have all this stuff. We have all this compute. Why do we even need the cloud? Why do we need to host things online when we can just host things at home, right? Like, it seems so obvious. Well, basically, I'm sad to tell you this, but the game is rigged. Home networks and phone networks especially are really locked down. You can't run things on them. You just have to be a consumer. You can only consume. You cannot run things like servers or things like that. I'll talk more about that in a second. We have these things called browsers, and it's almost in the name, browser. You can only browse things. It's really hard to contribute. They can only connect to servers, which are meant to be in the cloud. And basically, the entire economy online is made towards like mining your data. Not that that's necessarily bad. Like I feel it's bad, but like there's also probably good mining. Coal mining was good at some point. Now it's not so good anymore. But like, hopefully we'll get there with data mining where it's just as stigmatized. So yeah, I mean it's really hard. So I'm always saying we need a fresh start. We need to like back to basics. Think about what it is we're doing here. We basically need a new peer-to-peer internet. And you probably heard a lot about this in general. People talk about this online. There's a lot of blockchain stuff and stuff like that. Use this. But like, I mean actual peer-to-peer internet. Like, no bullshit, just like users in control, running programs. No difference between client and servers, although some people, I'm not saying everything has to be a server, but why do we have this difference? Like, why can't we choose when we're just running software? Just computers, right? Like, that's why I love running JavaScript, because it's like, it just abstracts away the computer. It's just like, I don't care if it's like on a watch or a phone or a laptop, it's just JavaScript. Except when I have to deploy things, because then all of a sudden I have to care, so that sucks. Obviously, anything we do today, these days needs to be private and encrypted per default. Like, that's like, I hate it when websites put like that feature saying it's encrypted, and I'm just like, what was it before? Like, it's kind of like when McDonald's has that ad that says like now 80% beef, and you're like, okay, so that's not really a statement. It's more like, an admission. And like, while there's like tons of functionality in like blockchain tokens, we don't need something that has to have a token per default. So like no built-in token that you have to pay to use it. No like shitcoins or anything like that. Just infrastructure, and then we can add things on top. And there's tons of use cases for that kind of stuff. So yeah, peer-to-peer internet, right? It sounds pretty easy. It's just like you put peer-to-peer in front of internet and you're done. Really not. It's actually really hard. So basically, the things we need to build something like that is a lot. We need, like I said, connectivity. We need to be able to connect to things. Need to be able to run things at home or on our phones. We need tons of data structures to efficiently, share data and send it around without having to connect to the same devices all the time. We need encryption, authentication, privacy, etc. And we need payment infrastructure so we can actually do services that are paid. Because like the peer-to-peer internet doesn't necessarily mean that everything has to be free, but it means that users should have the choice whether they want to charge for things or not. And I can talk about this for like probably a month. I won't. I will just talk a little bit about connectivity. So basically, if you ever work with like connectivity, i.e. connecting things, you'll find out that when you're at home, you can't do anything. Like if you try to play like a LAN game or something like that online, it'll probably just not work. That's because home networks and especially office networks are really locked down. Part of that problem is IPv4. I don't know if you're familiar with this, but like there's basically two versions of IP. The address is online. IPv4 is the old one. Problem goes kind of like this. If this is you and this is your router at home, that thing you got from your ISP, and that thing up there is the internet, that's kind of like how it used to work. You connect to your router, they'll connect to the internet. Then it turns out we didn't have that many addresses because somebody was like, just put a small number in there, it's fine, it'll be fine. So we ran out of IPs. So there was a really clever solution to this. I don't know if you know it. It's just like, fuck it, we'll just add another router. So like, we just don't know. So just in between your router and in the internet, there's just another router. So now you can probably log into this one at home on your home network. That's like that log in and mess around with settings, but doesn't really help you if you can't get to the next level. But then it got even more interesting because then we ran out of IPs again, because it turns out we have a lot of devices. But there was very luckily a solution to that. We just added another router. This is basically your phone. Your phone is down here, and that's the internet. So that's basically why nothing works on phones in terms of like servers and stuff. I made this little meme because I thought, I don't know if you're from back in the day, but it was a pretty good meme when I was online. So I often tell this, and then people are like, whoa, IPv6, it's a new one. It's way longer, it has tons of numbers. It's really long, we'll be fine. And it's true, like it helps, because IPv6, we can kind of collapse this stack down, and we just have one router. But then the problem is just like, ISPs, your internet provider are like, you don't really want people to have traffic coming in for security reasons and other things, so they still lock it down. And then this other very interesting problem happened that is like, this is a graph of IPv6 adoption. So like basically IPv6 was made and we had to update all our devices. And in the beginning, it went really good. And I don't know if you can notice, but the curve is flattening out a little bit. And that's because there's this very interesting market mechanic happening where the more people use IPv6, the more IPv4 addresses are available. So they become cheaper, so people buy them. So it's kind of like, as adoption grows, it slows. It's kind of sad. So we'll probably, I heard like the pessimistic prognosis right now is like 2200. I think we'll have IPv6 everywhere. And like obviously there's optimistic ones that are more realistic. So I don't know, like either global warming will kill us first or we'll have like peer-to-peer connectivity. But like, I don't know what you would prefer, but yeah. So basically to accept any kind of traffic, we need to trick servers and routers. Sorry, we need to trick routers into accepting traffic. So it's just a bunch of hacks, basically. And this is called Holepunching. And that's why we named the company that. So that's pretty cool. Also, it has an emoji. So quick primer, if you're not familiar with Holepunching, imagine this is a computer, and that's another computer over there. And that the shields are it's like your net, or your firewall, or your router, whatever you want to call it. Basically, what happens is if you send a packet to the other computer, it goes through your firewall, or like it's actually not your firewall, it's like your firewall. And what happens there is, as soon as the packet leaves, goes to the other place, your firewall will say, cool, you're a client. I love clients. We're all about clients. So I'll allow you to get a reply back from that address. But then as soon as that packet hits the other person's firewall, it'll be like, nope, you're not a reply, so I'm just going to throw it away. Like, I don't want to hear about this. And the trick is very simple. You basically just, after doing this, send a packet the other way. Because then when it arrives at the other person's firewall, it'll be like, oh, okay, cool. That was totally that reply to that message I sent before. So like, you're just like doing clients both ways. And if you do it like timing-wise, everything kind of works. So that's pretty cool. So we're just tricking them into thinking they're both servers, but they're actually just clients. And then the packet arrives. And then the cool thing is, as soon as we do this once, we can kind of use this station forever, and then we can just send like terabytes of data and abuse your ISP, and you'll probably get a call being like, why are you sharing terabytes of data? And you'll be like, I pay for it, so fuck off. So it's awesome. So anyways, yeah, this is cool, but the problem is it only works if we have what's called a stable address, which basically means we need to have an IP identifying the computer, and we need to know the port that the ISP opened for us. IPs you can find easily. That's I don't know if that's a feature. It's like basically not very private. You can just go to websites and they'll tell you your IP. Ports are chosen in secret. I chose to phrase it a little bit conspiratorially here because I thought it was more fun. But like basically you don't know what your port is, but you can just ask other computers what your port is, and then if it's like static, i.e. the same, which actually most ISPs give you, then everything is fine, and then you can just have the computers tell each other, and it's like this whole gossip network, and everything is fine, and we don't have to worry about it ever again. So that's cool, except when you're at work. I don't know if people work here, but I have an office, and when you go to the office, I think they're probably just very scared of BitTorrent from back in the day, but like they just lock down everything. They're like, nope, no known ports. We just want no traffic. We just want only traffic going out. So they do this thing called randomization, where they just like that number, the port. They can't. It's pretty hard to fake the IP, but the port is just randomized for every connection you do. So you can't guess it. So that's kind of unfortunate. But luckily, we can hack that also, so that's pretty cool. So I don't know if you've ever seen this technique, but it's pretty fun. But basically, it's just like math. I studied math, and this is the first time I used it in practice. That's pretty cool. By reading a blog post about a technique that somebody else described, but whatever. So basically, ports are very small. They're between 0 and 60,000, 2 bytes. So if one of the computers has a known port, i.e. is at home, and the other one is at work, has a random port, but we can assume we know its IP, then basically it's a guessing game of like, one computer we know the port of, the other one we don't, and like we can't look anywhere because it's hidden at the ISP. So like the first technique is very simple. We just guess, just pick a random number, send a packet over. It's not that good because it only works 1 out of 60,000 times. So basically like we do that technique before where we send a packet over, open the session, and then we just guess a port and send it back. And if we guess it, it's really good. Then we have Holepunch. And if we don't guess it, it's pretty bad because then it won't work, and we won't know that it didn't work because it'll just get dropped. So how can we improve it? Does anybody have any ideas? All right, it's actually really simple. We just do it tons of times. So basically, instead of like doing one port, we just open 256 because it turns out they don't charge us for that. We can just open as many ports as we want. Also at work, you can do that at work. It's pretty cool. So when you want to connect to somebody and they're on an office network, you just have them spin up tons of ports, and then they just open a session on all of them by sending a packet to you, like that. So now all of these firewalls here will accept a packet coming that way. But again, they still gotta guess the port. So instead of just sending one random packet, we just send a ton of them to random ones, and then if we guess one of them, it goes through, and that's really awesome because then we have a Holepunch connection. We can send terabytes of traffic to work, so that's cool. So I don't know if anybody has any intuition about like the math about how many guesses do you need to do if you do like 250 sockets. This is like a trick question because like obviously it's hard math when it comes down to it. Because when you do this, you're probably like, oh, you probably need to send tons of traffic. Well, it turns out you really don't. This is very similar to a problem called the birthday paradox, which is like basically how many people do need to be in a room for 2 people to share a birthday, and people are always like, oh, 300. But turns out it's like if you have 20, it's like 50% chance that people share a birthday. And that's basically because of math, because you're not comparing unique numbers, you're comparing pairs. So it's like factorial math, and it makes everything easier. And it turns out this is a product of that kind of factorial math where we're guessing pairs, we're not guessing unique numbers. So since we open 256 and there's 60,000 options, we actually only need around 170 guesses to be around 50%, which is pretty mind-blowing. That's to break into your corporate firewall that your sysadmin is like, ha, it's locked down. And if we send around 2,000 packets, it's like 99.9, which is basically like certain, right? That's basically it. So basically it means like we can break into any network. So that's awesome. We can do all the connectivity. And people always, when they say this, it's like, wait a minute, I read about this, because this sounds like an attack, like we're like DDoSing people. And we're like, yeah, actually, yes, it's kind of true. Like we're just like port scanning and attacking. And like firewalls hate that, so they'll like block you. But we can do this final trick, which is like, Basically, packets don't need to arrive; they just need to exit your network because you're opening sessions. So I don't know if anybody can spot what the trick is if you're like a network person, but like you can basically just lower the TTLs on your packets, which just means that they just leave your network and then they die, which is like enough to trick your end. But your end is fine because you're attacking yourself and your routers are like allowing that. So basically, like you're just sending tons of packets going nowhere, and that's like, oh, sorry. Yeah, well, basically just results in this thing where like your ISP doesn't know it's being attacked. So like, they just do a random guess at the end and like, oh, that's true, cool, okay. So a little bit more to that. So that's awesome. Oh, that was a little video there, that's cool. So I have a quick demo of that. I hope, how are we doing on time?
It's 20 minutes
Left. Okay, I'll be fast because I want to get to the app also, and I lost some time. So let's see, so now this is gonna get a little tricky. So I have my own computer over here, and I have Andreas' computer here, and I SSH into my own computer, and I'll make it a little bit bigger so people can actually see it. And this is it's an English keyboard, so it's all good. All right, so basically, I made this little script here that runs a server on my computer using this thing called Hypercore, which is the thing that we use for connectivity. That's not the app. I hope we'll get to the app. We also need to test that the app runs on this computer. Anyways, here I'm just like making a server. It's spinning up that P2P thing, and it's printing out a key pair it's listening on because in the P2P world, everything is key pairs. So I'll run the server, and it spits out this key it's listening on. It's just the address of my computer now on this P2P network, this internet. So I can copy this, and then on this other one, I'll also increase the size. And then I have SSH running on my office computer. This is just a shortcut to get into that. That's actually breaking into my office now using that technique. So now I'm inside my office that's behind a so-called corporate firewall. So this other one here, the left one is in Germany here, the other one is in Copenhagen in like a hard network. Anyway, that's fine. So if I go in here, I just have the same code but a client. So when I run the client, what will happen is I'll paste this key and they'll find each other using this, whatever, it doesn't matter. And then they do this technique where they break into each other. And I added a log so they just print out the progress because it's kind of like James Bond. It's the only thing I've ever done that's like James Bond IT, when they have the cracking thing. So let's try client. So now they're like cracking each other using that technique where they're like trying to guess the numbers. And let's see if it works. It's taking a little longer than normally. So now at the end there, they found a pair. I don't know if you can see, but this one says connection. And this one over there said that the server said something, and that just says hello world. So basically that's what happened. They opened up and they were like trying to, trick the routers, but none of them saw this traffic. It was just like going in and out. So yeah, anyways, that was it. So back to the slides. Demo. So yeah, connectivity, that's how we do it. Cool, first part done. So basically I work on this thing, it's called the Holepunch platform that just solves all of it. So that's all you need to know. Like we solved all these problems. We worked for 2 years to bundle all this up in like simple APIs that users can use. We haven't launched it yet. That's launching later this year, but we built some apps on it, and that's what I'm going to show now. So basically, like it allows you to build what we call unstoppable apps because, even we can't take them down once we release them because they're peer-to-peer. So that's always nice. And the stealth app I talked about earlier is actually this app called Keat. It's a peer-to-peer video and chat app that uses these techniques to do fully private video and chat communication, all peer-to-peer, like just between each other and multiple people, everybody at work, and like chat and stuff. And I have that installed on my computer here, and I'm gonna try to install it now on Andreas. On Andreas' computer. Okay, cool. We'll do a demo. So it's kind of scary now for me because the first step of the first step of this is it has to fetch itself on the peer-to-peer network. which I did on my computer already. So let's see. So this is what's happening now. It's just going out into the network. I have no idea if this is going to work. Yeah, I think it's going to. Goes on the network. It finds the app itself, because this is just a little bootstrap code that like gets the code down for the app. And this is the app. It's a little bit hard to see down there because it's all dark, but this is like very simple. Now I have my next challenge is I'll need to get a key across, but that's fine. Oh, I can just connect to myself over here. Never mind. So basically, this is the app. So this app came from like tons of peers using the app right now. So they all shared the app with me using that installer I had. I can go in now and I can make a room. And I would like to access the camera. Sorry, Andreas, I'm just going to say it's okay. And then also the data and the payment info. And then, I'm just kidding. So this is the app. So this is like a very cool peer-to-peer chat with myself. I have a chat over here. I can write. Right now I'm just writing to myself. So it's a little bit boring. But like all of the data goes locally. Nothing leaves my computer because I'm not connecting to anybody. But what I can do is I can add people. So I can copy this link here. And this is a little bit gnarly link. So, that's my office. That was wrong. So this link, this is my computer still. So what I'll do is I'll open Vim. And I'll just paste the link here. That's the link to this chat. So that's this cryptographic link that identifies me. And I'll just save it. This is very fancy trial transfer between this computer and this computer. So, and I'll go back and show the app. Cool. And I'll do Keat here. So what I'm doing over here now, you don't have to see it because it's pretty boring. I'm just clicking that link, basically. And just gotta start the app now. So now it's cool because like these computers are connecting to each other to actually get the app if there's an update and stuff. But so it's really fast. So now over here, I'm joining the room. So now, sorry, I should probably mute this before this goes really crazy. So now I'm in a meeting with myself. But the cool thing is peer-to-peer, right? So it's like this just between these two computers. And it doesn't matter what kind of network this is on. And I still have the chat here, over here. And that's also swarming. And all this, the chats and all that stuff, it's not just like sending messages over. It's using these fancy data structures where we can have billions of chat messages. And we can take them with them. And they only sync the diffs and stuff like that. And not the history. And I actually have some colleagues. I might as well try to see if they can get on. Andrew. So I send this link now to my couple of friends of mine. I don't know if they'll see it. Let's see, because we were a little bit delayed. I told them to be ready. But basically, I can also do stuff here like on this computer, share files. So what I'm doing now on this computer is just like going in to my files, adding a file share here. There's David. Hey, David. He said, yo. It's like a little bit of this. Share files, and the cool thing, David, can you share a file actually? Put in here? He said, yeah. So that's cool. So basically, the cool thing is whenever you share data, you're not sending it to each other. You're just adding it to these data structures. That's Andrew. Hey, Andrew. I got two computers because like my computer is not working. So, but the cool thing is I installed this app on a new computer, and it totally worked. First go live, nothing, no strings, nothing up my sleeve. So the cool thing is when people add data, so David here added something, I don't know what it is, a video. It's our like marketing video. So I can seek around in this stuff, and it's only syncing the parts of the video I'm in because it's just syncing from the people in the call. So even if David added like a terabyte video, I would see it immediately, but I could then just like watch it, just the parts I wanted to, and then obviously when people go offline and I haven't synced it all, I can only watch the stuff I've seen already. There's no magic. It's not like we're like, oh, just putting it up. But like nothing in between, no like middlemen storing it or nobody. And it's all end-to-end encrypted and everything. So it's pretty cool. And also it's kind of hard to see here, but we kind of noticed like the quality is just really mind-blowing. Check this out, guys. There's like a ton of guys in here. I don't know. I hope you're okay. It's only between these guys. You recorded that, right? Yeah. No. So So that's basically that. I'm gonna leave the room now, but thanks you all for joining. And we got like things like screen sharing and stuff. Oh, Andrew Raven. The cool thing is, since it's all local, like every time you make a call, you can just enter the call again. So I'm gonna enter it now. I hope nobody took their clothes off. That's all good. I think David is turned off the camera, but that's fine. Oh, there we go. So basically, it's all there still. It's not like you have to talk to a cloud. I can turn off the internet now and it go in and it's still there because there's like no tricks. So yeah, that's the app. Super simple. We're adding like tons of features to it. More file sharing, more scalable chat. And now, before I get in trouble, I'll go back to my presentation and finish it up. So basically, we're releasing officially next week, but you can try it out now. We're calling it an alpha because we're still working it out, but it won't delete your system, but also no promises. You can get it at Keat.io. And join the peer-to-peer internet. And like we're launching the general platform so you can build your own. This is all just a very simple like front-end app, basically. We're launching that later this year, and if you follow me on Twitter, I'm sure you'll find out. Thank you so much.
Thank you so much for this beautiful talk.
It went pretty okay, I think, right?
Yeah.
All the drama. We had drama.
It's like I'm super impressed. We had all these technical problems. We were starting a bit late. You showed, I think, everything you wanted to show. We've learned a lot, and you still finished 5 minutes early.
Oh, okay.
So that's how you recognize a pro. Do we have any questions? And I will include the Slack questions here. I'm not being impolite. I just want to include those people as well. Okay, we'll start maybe from here.
Is the question when you get your computer back?
Yeah, now I wanted to ask whether you download all the files on my computer peer-to-peer to yours, just like through the Wi-Fi. No. I was asking myself, do you have the same issue that other peer-to-peer systems have with video conferencing and large scale, where you say, okay, if you're like 50 peers, you kind of have to send your video to everybody, and that's gonna.
Yeah. So like, so we do this thing where we have this intelligent. I call it intelligence, very silly, but like relay system where peers will amplify other peers' video, and it's not perfect yet, but it like we're improving it. But basically, it means that, for example, here I'm on local networks. If you're in the call, it's kind of silly that these two computers both go to you. If you're on a different network, they should obviously just get it from each other because that's very, very fast. If I'm on my home network at home, I have fiber, I should send more data to other people. I shouldn't rely on other people's potatoes networks, like amplifying it. So we're doing techniques like that, but we're still improving them. But I'm actually personally, once I started working, especially with video, I was very surprised, how little data is actually being sent. It's just because it's a little bit of data sent a lot. That's why things like Google Meet and things like that don't really like it. They throttle you a lot because you're only sending a little bit of data, but you're sending it like in an hour. So it's kind of like, you're very quickly sending like 50 gigabytes, which is very expensive if you're paying for it as a host. And as soon as we take those breaks off and we just use our home connections, even when we're on really slow networks, like 10 megabit, I don't know if that's allowed to say that is slow, but like in the grand scheme of things, the video quality is actually really amazing. So you can get really far in peer-to-peer things, but obviously you need to do tricks like amplifying it. And also, peer-to-peer doesn't mean no additional servers, or not even servers, but like my office network is really fast, right? I can run a service there that just amplifies traffic. I just don't need to use the cloud. And then obviously, maybe you want to charge for that and stuff like that. But yeah.
Yeah, hi, I'm Madsen. Thanks for the great talk. When setting up the connection, I was wondering, how do you know the IP you want to connect to? I mean, thinking in terms of, I have a contact list and I want to contact a certain person. How do I know his IP at the moment?
Yeah, that's so we've got an hour left, or no? No, it's a really, really good question. And basically, we use this thing called a DHT, which is a distributed hash table, which is kind of like this fancy global network where you can associate, a little bit of metadata with something. And we use this advanced technique where many peers will tell you a little bit about something you're looking for, and you actually identify it by a public key that only you can identify, which is kind of like an address, like an IP, but just a cryptographic address. I'm not explaining it well because I got to do it in 1 minute, but basically you're just announcing to this network, which is just other people's computers, a little bit of data that says, I'm this key if other people are looking for me. They can relay traffic, a little bit of traffic to you there. So they relay a little bit of traffic to you there, but you only need to relay a little bit to establish this very big connection afterwards. You need to have what's called a bootstrap node. Somebody needs to introduce you to other nodes, and we just run some bootstrap nodes. But as soon as you talk to them, you don't need to talk to them ever again because every computer is equal. So as soon as you get introduced to another one, so basically the more people who run it, the more private it is, and that's what BitTorrent does also. So obviously, it's actually pretty funny. I don't know if you know this story, but like Tor, the very private network. Tor was like made by the U.S. Military for spies, basically, to be, if they're in the field, they want to send private data to each other. The problem with that is that if you have a private network and there's 2 people in it, it's like, doesn't really matter because it's just like, oh, there's 2 people using it. So the conspiracy theory is that's why they wanted to use it for drugs and stuff, because you want to get a lot of noise in there so, the spies can hide. And that's like a classic conspiracy theory. But basically, it's just like, the more the network grows, the more private it gets, which is a good feature instead of the opposite.
We have one question from remote. The question is, so the first client to join a room is also basically creating it, isn't it? No central registry of rooms anywhere.
Yeah, so actually they're all creating it. They're just all like joining their part of it. So you're in control of your data, but they're building this shared data structure where they're all, it's kind of like, if you saw the chess talk before, I was talking about shards, like when you split a database up into many pieces, they all have their own shard of it. But by clicking the link, they have enough cryptographic information where only the people who click it can join it and stuff. Again, 10-second explanation to like a 30-minute question.
Perfect. More questions? Yes.
Thank you for the very interesting demo. You talked about the DHT, the distributed hash table. Do you build your own network there, or are you using a specific one that's existing already, like IPFS or something?
We run our own, and I think actually most people who make something with DHT runs their own, because when DHTs have a big downside that's like every node has to provide the same amount of offerings, because otherwise the capability that I talked about, where you can just, there's no differences between nodes, goes out the window. And for our hole punching and our techniques, we need some specific methods. And you can try to get that into other people's things. And we've used to use the BitTorrent DHT in the past, but it's really hard because then you change it and it gotta go through again. So most people end up running their own, but I would love for somebody to solve that and we could all just run one happy one. Because again, the bigger it is, the better. So it's like just a downside that we run our own. So we do run our own because we need to do these very advanced hole punching techniques that is very, very specific.
Hey, Mathias. Thank you for your presentation. If I understood you correctly, the next week or very soon you're releasing Holepunch?
So we're releasing this app that I just showed. It's actually not released. That's why I'm like, don't tweet. But again, this is coming out next week, and then we're announcing this platform. And the app itself is built on this Holepunch platform. That's not releasing next week because we're still building out the tooling, but it's coming later this year. And also we're making it for mobile. So you can run peer-to-peer apps on mobile, because using these crazy hole punching techniques, you can actually make phones connect to each other directly, which is like really game changer.
Okay, so it sounds very exciting. So my question is, as a Node.js developer, as an application developer, do I need to learn or do I need to know networking to build a platform with this?
Yeah, you need to be luckily, that's actually like all the time. That's all the time I spend is thinking about you as a developer, how little you need to learn by using our tools. So basically you don't. Like I showed very quickly, but basically, it's locked out, but whatever. Like basically, if you've ever done things with Node.js and HTTP, like you make servers, you make clients, this is as easy as that. It's like you just make a server, you make a client, we have data structures, but it's kind of like you make a database, you run queries on it, and it hides all of that craziness from you. Obviously, there's times where things are different. Like, with peer-to-peer, queries tends to run a little bit slower because they're like going through the world. When you're querying a database and you want to get a result, it's a little bit slower because it's like going to many computers. But then when you run it the second time, it's way faster because it's all local, right? And it's only needing a little bit more information to run it. And you need to think a little bit more about that as a UX developer, because it changes the equation a little bit, where like the experience gets better and better the more the user uses your app, which is kind of weird. No, all our APIs are based around that. And like writing our video app with the chat is basically equivalent to writing a website.
Very exciting. Thank you very much.
Yeah, also thanks my side. How concerned are you yourself about criminal use of this?
Criminal use?
Yes.
I mean, everything has criminal use, and like obviously peer-to-peer has criminal use also, and tons of centralized systems have criminal use also. Like, it's actually an interesting question because people always ask me that because there's this implied thing in peer-to-peer where you're like, this is for criminals, but like the rule of law still exists in a peer-to-peer system. Like people also ask me like, what if people steal my data if you share it with them? Because it's like, not that you can't, but like if you share a link, you can get data, right? And I'm like, well, the law still exists. Like, you know, you can still sue people if that's what you wanted. If that's illegal, if they stole it from you, it's still fine. So to answer your question, I'm as concerned as I was making centralized solutions. And I was told in the beginning, I used to run a file sharing site, and I've seen up front all the crazy things people share and like criminal stuff like back then we had to deal with because that's just what happens. So it can be used for good and it can also be used for bad. But like obviously, I think that the upsides of it are vastly better than like potential downsides.
Is it at the end more private than, for example, the Thornet network?
Then what? Sorry.
The Thor network you also talked about.
Tor to me is built around privacy with a ton of downsides. Kind of like not downsides. Sorry. What's it called? Trade-offs. You know, Tor goes out of the way to always make your experience private. Like I said, it's made for spies. Like they don't want you to ever be able to find anybody. So it's all about being anonymous. And anonymous is not the same as privacy. Privacy just means that data is secure, but sometimes we have to do a trade-off where we don't like route all the data through 8,000 peers to hide exactly the locations. So sometimes your ISP can figure out in a peer-to-peer system that two people are talking to each other, but they don't know what. But like we take all, but that's the same. That's the same if you go to Wikipedia, they can see you accessing Wikipedia. If you're going to a porn website, the DNS provider can also see that, right? Like that's kind of like the same trade-offs. This is way better than that, but other things like Tor take more trade-offs to be more private, and we take more trade-offs to be faster.
Thanks.
Do we have any more questions? We would have some more time.
There's one
yes,
in
at the back.
Some hard questions. It's good. I love it.
Thanks for the insights. There have been several other projects like Briar or FireChat or you name it, doing similar stuff.
Mm-hmm.
I wonder how yours is different and what for target, let's say, audience you have for your app. Yep. Because in my feeling, it's like all about market share and critical mass with communication tools to get them anywhere, because no one wants to install yet another client to communicate with someone.
Sure, yeah. I mean, obviously there's tons of things that call themselves peer-to-peer, and there also are peer-to-peer things. Most things are pretty lackluster in terms of like failing when networks are a little bit weird. That's actually something that happens a lot. If you're not on a perfect network, things won't work. And then they often just fall back to routing things through a server. That's like, if you ever go to the online and you go to a so-called peer-to-peer website that's like doing video, what they often will just do is route it through a server because the peer-to-peer thing didn't work because the browser has very limited APIs for this kind of stuff because they don't really want peer-to-peer traffic in the end. So basically, by making a dedicated app and also by focusing on phones, which is like something we do a lot, we're in a pretty good position in terms of other apps. We're actually not trying to make a peer-to-peer app. It's just because I like to talk about it. We're trying to make a good chat app. We're trying to make an app that's just like better than other apps. So like what we discovered when we use this app a lot, we use it for all our communications internally, is like, it's better than centralized alternatives. Like the video is better, much better. And it creates a whole different experience because when you're watching somebody in 60 frames per second, because the traffic is flowing directly with each other, it feels much more, you feel much more close to them because it feels less remote. And it sounds weird, but it's something that happens. File sharing, because you have that built in, you can start using it as a tool where you just like, there's no one of those nagging, you upload 20 megabytes, now you have to sign up or do something with it. It just works. So we're actually just trying to make a really, really good app. And other people also obviously trying to make a really good app, but we're just trying to make an experience that's like really solid for users that are not technical. And I think also in like, what's interesting in this time and age we're living in is that privacy and this whole like awareness that, oh shit, like, we're sending all our data to the US or to China for that matter to be mined to death. Maybe that's not the best idea in the world. So, I'm on the feeling that people are finally waking up to this idea that maybe we should be more in control, so that obviously the market will grow massively. And final thing to that is like, at the end of the day, we're building a chat app, but we're also building tons of other apps. That's why we're building a platform out, because we want to make a whole revolution where your entire ecosystem runs on peer-to-peer technology like this. So like, all the apps you use are, that's the default. It's not the special case. So in the future, you'll ask that question to somebody making a centralized solution, being like, why are you competing on the same tiny market share with something else? Yeah.
Okay, we would have time for one more question, if there's still one. Yes, final question.
I might not have get it, but I'm still curious what you did. So you started on one machine, a server, spilled out a hash or
public
whatever.
key, yeah.
Okay. Then you went to your office, started there a client, and gave it as an argument.
Yeah.
How could your colleagues join?
On this other computer that you couldn't see, I sent them a link on a text message saying join that's the similar link, that's like a key.
Okay.
But that key, they just find me on the network, the internet.
Yeah.
And they connect.
You used another means to share that key, right,
sure.
to that session. So you still depend on another communication channel, right?
Well, let me ask you this, like when you call your parents, do you type in the number in the phone?
Yeah.
Or maybe you're German, so maybe you do, I don't know. But like, you have a contact book, right? Like you probably have a contact book saying mom, dad, or like your friends. So like, pairing is always hard. Like pairing, this is basically pairing, like sending a phone number, okay, it's a little bit easier than a 64 character key, but it's still like 5, 2, 6, blah, blah, blah. Once you're paired, we're connected. And then it's just like, I can just go into the room and we can make new rooms. We don't have to do it again.
So it means if someone eardrops that key, whatever channel you choose, right?
Yeah.
So he can join that session.
We have different kind of keys, so we can also have ones that's like only works for one person, and we can also, if you know the other person's ID, you can invite them that way. So we have control that way, yeah.
Thank you.
But it's a really good question, and it's like something that get asked a lot, and it's very interesting. I don't know if I'm allowed to talk anymore, but like a lot of people ask that, and they're like, why don't you put a name on it, right? Why don't you just put like a domain on it? But as soon as you start naming things, trouble starts, because then you need a registry, you need a centralized thing that's in control. So it's much better to think of this as pairing, like kind of like you pair your Bluetooth speaker with your computer. It's also, you don't care what the address is. It's just you click a button and it works. Kind of like with this, we just need better systems for pairing in general, like QR codes, pictures, maybe play a sound and it adds. And you only should do it once. That's my main takeaway.
We got one more question from the remote, and since they're not able to ask this during dinner, let's say the ISPs don't like Holepunch and want to strangle it. Could they?
Well, it's an arms race. That's what we always say. It's kind of like when you're David versus Goliath, the bigger your opponent is, the easier it is to strangle them. But as you grow, it gets much harder. Like look at BitTorrent. I think BitTorrent, I love talking about BitTorrent. I worked a lot with it in the past. It's like, it's the most, like when it comes down to a criminal thing, right? It's like share movies without paying for it, and they couldn't stop it. Why couldn't they stop it? Because it was built on unstoppable peer-to-peer technology. The only thing that stopped BitTorrent in the end was Netflix, because people were like, oh, I can pay for it. It's pretty easy now. Like that. Now I don't have to be criminal anymore. That's cool. But like it showed you that, once things get momentum and get big enough, you can't do anything because people will find a way. Like traffic's encrypted. How do you identify this traffic from other traffic? La la la. So yeah.
Mathias, thank you so much for this beautiful talk. We've heard that you like the cars here a lot, so we organized you some cars to take home.
Oh, really?
Yeah, they're chocolate,
awesome.
But they're still very beautiful.
Thank you very much. Thanks so much.
Thank you so much.